Hello and welcome to Excel Mathematics TV. This presentation will be about comparing and ordering rational numbers. A rational number is any number that can be expressed as a over b, where a and b are integers and b is not equal to 0. In this lesson, we will learn how to compare and order rational numbers. There are many types and forms of rational numbers. In general, it is easier to compare them if the numbers are written in the same form. So let's talk about how to compare each form. If the given are fractions, we need to rewrite each fraction with a common denominator using LCD, then compare just the numerator. Another way of comparing fractions is converting them to decimals. If the given are ratios, it's better to write them in fraction form before comparing, because it's difficult to compare if they're in the form of a ratio. But what if the given are in different forms, like percent, decimal, fraction, and other forms of rational numbers? How do we compare them? It's simple. Express them in the same form and then compare. Now that we have an idea about rational numbers and how to compare them, let's dig deeper and study how to compare fractions. We need to have examples in order to learn it in a more effective way. We will write less than, greater than, or equal to in the box to make the sentence true. Let's use two methods in comparing fractions. The first method is by expressing the fractions with the same denominator using the LCD. Since this method uses LCD, the first thing we need to do is find the LCD. To find the LCD, we need the multiples of the denominator. The multiples of 5 are 5, 10, 15, 20, 25, 30, 35, and so on, while the multiples of 6 are 6, 12, 18, 24, 30, 36, and so on. As you can see, the common multiple is 30, and it is the least. Then the LCD of 5 and 6 is 30. Now that we got the LCD, we can finally express each fraction using 30 as the denominator. To do that, we'll think of a number for each denominator wherein, when multiplied that number to that denominator, the product will be 30. For the first fraction, 3/5, we will multiply it by 6 over 6, and the result is 18 over 30. And for the second fraction, 5 over 6, we will multiply it by 5 over 5, and the result is 25 over 30. Note that even though we're multiplying the fractions, their value stays the same, since we're just multiplying a fraction equal to 1, like 6 over 6 and 5 over 5. Now the denominators are the same, and we can easily compare the fractions. Simply compare the numerators 18 and 25. Since 18 is less than 25, 18 over 30 is less than 25 over 30. That means 3/5 is less than 5/6. Let's use another method. This time we will be using decimals to compare the fractions. Since this method involves decimals, we'll start by converting the given fractions into decimals. It's simple. Just divide the numerator by the denominator. So we have 3 divided by 5, and the quotient is 0.6. For the second fraction, we have 5 divided by 6, which is equal to 0.83 repeated when simplified. Now let's compare the decimals. As you can see, 0.6 is less than 0.83. Thus, 3/5 is less than 5/6. We got the same answer as before. We're done with fractions, so let's move to the next topic. Let's learn how to compare ratios. As usual, we will solve an example in order to learn. So let's start. Joel can run 4 kilometers in 30 minutes, while John can run 3 kilometers in 15 minutes. Who is faster? In this problem, we can express the given in the form of a ratio. Let's write the ratios in kilometers to minutes. The ratio representing Joel's speed is 4 to 30, while the ratio representing John's speed is 3 to 15. Remember what we said earlier about comparing ratios. First, we need to express the ratios in a fraction form and simplify if necessary. The ratio of 4 to 30 would become 4 over 30, or 2 over 15 in simplest form. And the ratio 3 to 15 would become 3 over 15. This is already in simplest form, so no need to simplify it. You see, the denominators are already the same. This is easier because we don't need to express them as similar fractions. We'll go straight to comparing the numerators. Since 2 is obviously less than 3, 2/15 is less than 3/15. That means 4 to 30 is less than 3 to 15. Thus, John is faster than Joel. To help you compare rational numbers easier, let's see these fraction, decimal, percent equivalents. These are some of the commonly used fraction decimal percent equivalents. Try to always remember these, because it will make solving easier and faster. For the next topic, we will use what we learned in ordering ratios. Let's have an example. We will order 0.24, 18%, and 1/5 from least to greatest. As you can see, these rational numbers are in different forms. We can only compare the ratios if they are written in the same form. Also, we can solve this problem by writing the given ratios in decimal form. Since the first number is already in decimal form, we don't need to touch it. So we have 0.24. To express 18% in decimal form, we just need to drop the percent sign and move the decimal point 2 places to the left. Then, the equivalent decimal of 18% is 0.18. Finally, 1/5 is 0.2 in decimal form. This was included in the commonly used fraction decimal percent equivalents. But in case you forgot its equivalent decimal, you just need to divide the numerator by the denominator. Now, all the numbers are in the same form, and it's time to compare the decimals. As you can see, 0.18 is less than 0.2, and 0.2 is less than 0.24. Thus, the order from least to greatest is 18%, 1/5, and 0.24. For the next topic, let's try writing the given ratios into fractions with the same denominator. We will solve the same given. For this one, we will make all the denominators the same. We will make them 100. Since the first number is in decimal and is read as 24 hundredths, we can express it as 24/100. Percent means per 100, so 18% can be expressed as 18/100. For the last number, which is a fraction, we will make its denominator 100 by multiplying 20 to the fraction, just like this. Then we will get 20/100. Now we can compare. Since 18 is less than 20 and 20 is less than 24, then the order of the fractions is like this. 18/100 comes first, followed by 20/100, and the greatest is 24/100. Thus, the order of the original given rational numbers is 18%, 1/5, and 0.24. We got the same order. Let's dig deeper and learn more about rational numbers. I'm sure that you already know what a rational number is, but let's repeat its definition. Like what we have said earlier, rational numbers are numbers that can be written as a/b, where a and b are integers, and b is not equal to 0. This Venn diagram represents the different forms of rational numbers. Now, we know what rational numbers are. Let's see if we really know these numbers well. We'll be identifying rational numbers. Let's see if we can determine the number that is not rational among these numbers. Remember, a number is rational if it can be written in the form a/b. To know if the number is rational or not, we will try to express each of them as a fraction. -9 is -9/1 in fraction form. 0.3 repeated can be written as 1/3. We can't express this decimal in fraction form. And finally, 4/5 is already in the form a/b, so no need to change its number. Thus, 1.92457 is not a rational number. Our lesson ends here. Comparing and ordering rational numbers is easy if you know how to play with the different forms of rational numbers. Keep practicing and keep on learning. Thank you for listening, and we'll see you next time.